Welcome to the deep dive. You ready to go
Well,
deep? Today, we're going to be exploring the world of natural language reinforcement learning.
oh, yeah,
Pretty cool stuff, huh?
definitely.
Our source material is a research paper by Feng et al.
Hmm.
And it really lays out a vision for AI that can not only learn like we do, but can actually explain its reasoning.
In plain English.
Yeah,
Yeah.
in plain English. Like, wow.
That's really the key here, right? Like bridging this gap between, how AI learns and how we understand the world.
Exactly. Yeah, it's
Yeah.
like we've had this tool reinforcement learning, right?
Yeah.
Super powerful, but it's been this black box.
Totally.
We feed it data, it learns,
Hmm.
but like we don't really know why it makes the choices it does.
Right.
And this paper is arguing that natural language is the key to kind of unlocking that box.
Yeah. And, the idea is surprisingly intuitive when you think about it.
Okay.
How do we as humans learn complex tasks?
Right.
We get instructions, feedback, explanations, all through language.
All through language, yeah.
So why not apply that same principle to AI?
Okay, so instead of just relying on those simple rewards
Right.
that we see in traditional RL, NLRL uses human language to define tasks,
Yeah.
to like shape strategies, and even evaluate the AI's, thinking process.
Yeah, exactly. Imagine being able to ask an AI why it chose a particular action.
Oh, wow.
And it responds with like a clear, logical explanation in plain English.
Oh, that'd be amazing.
That level of transparency could be revolutionary.
I mean, think about like the implications for that.
Yeah, totally.
The paper uses a tic-tac-toe example
Okay.
to illustrate this.
Oh, yeah, tic-tac-toe.
So picture an AI playing the game, and at each move, it's telling you,
Oh,
like, oh, I'm going to block your win here, or this move sets me up for a fork.
Aha. Right.
So that
you
you're
can
not
see
just
it.
seeing an AI play, you're like understanding its strategy.
It's like getting into its head a little bit.
Totally.
Which is kind of freaky, but also really cool.
Yeah. Yeah.
But, it's a great example, but the potential goes way beyond games.
Oh, okay.
Like imagine applying this to something like a self-driving car. Instead of just trusting that the AI is going to make the right decision, you could have it explain its reasoning in real time.
Wow. In real time.
Yeah, that'd be a huge leap forward in terms of trust and safety.
That would be huge.
Yeah.
Yeah, especially with, all those concerns around self-driving.
Exactly.
Okay, so how does this actually work? The paper talks a lot about using large language models, or LLMs.
LLMs.
We know these are like behind things like ChatGPT,
Right.
but how do they actually fit into NLRL?
So LLMs become like the engine of the whole system.
Okay, pay attention.
Yeah, they're processing language, they're learning from experience and making decisions, all using their ability to understand and generate human-like text.
Okay, so they're really at the core of it.
They're the core.
I'm already seeing how this could get really powerful.
Oh, yeah.
The paper even talks about an LLM acting as a language critic,
A language.
evaluating a game state, just like a human expert would.
It's almost like having a built-in coach, right?
Oh, that's a good way to put it.
Analyzing the situation and giving you feedback, but all in a language that's easy to understand.
So are we basically teaching AI to think like humans?
Not exactly. It's more about giving AI the ability to learn and reason using the same tools that we do.
Which is
Language.
Language, okay.
Yeah.
The paper dives into some pretty technical stuff here, talking about language GPI and language TD.
Okay.
Can you decode those for us?
Sure. So think of them as like ways to guide the LLM's learning process.
Okay.
So language GPI, or generalized policy iteration, helps the AI figure out what actions to take based on the task and the current situation.
So it's like a set of guidelines or principles
Yeah,
to
exactly.
help it make the right decisions.
Right. And then there's language TD, which stands for temporal difference learning.
Okay.
This helps the AI evaluate different states or actions based on past experience.
So it's like the AI is reflecting on its past games.
Exactly.
Figuring out what worked, what didn't.
Right. All through language, though.
Oh, through language? That's amazing.
Yeah.
It sounds like the AI is building a kind of intuition for the task, just like a human would.
Yeah, that's a great way to put it.
But all of this seems incredibly computationally expensive.
Yeah.
Can we really scale this up to tackle real-world problems?
That's one of the key challenges the researchers acknowledge.
Okay.
Right now, NLRL is mainly demonstrated in simpler environments like games.
I like games, yeah.
But as computing power increases and LLMs become even more sophisticated, the possibilities are vast.
So what kind of possibilities are we talking about?
Well, they hint at using NLRL for things like coding and complex reasoning tasks.
Okay.
But what does that actually look like in practice?
Right. That's the question.
So imagine having an AI that can not only only write code, but also explain why it chose a particular approach.
Oh, wow.
It could act as a coding partner, helping you understand complex concepts and debug your work.
That would change the way we approach software development entirely.
Completely.
Yeah.
And it's not just coding. Think about any field where complex decision-making is involved.
Mm.
Financial modeling, medical diagnosis, scientific research.
Wow.
NLRL could bring a whole new level of transparency and understanding to these fields.
It's almost like we're giving AI a voice, allowing it to explain its thought process and collaborate with us in a way that's, truly meaningful.
Exactly. And that's where things get really exciting.
Let's dive deeper into those exciting possibilities in part 2. We'll explore some of the specific experiments the researchers conducted and get a glimpse of what the future might hold for this groundbreaking technology.
Oh, wait.
Me too. This is going to be good.
It is.
Buckle up, everybody.
Yeah, buckle up. So picking up where we left off the paper doesn't just kind of lay out the theory of NLRL.
Right.
It actually walks through how they built like a working system using these concepts.
Oh, that's what I love about these deep dives.
Yeah.
You get to see the rubber hit the road. So how they actually put this into practice.
Okay, so they start by focusing on the role of the LLM as a language policy.
Language policy.
Yeah, this is where the AI, powered by the LLM, looks at the task, understands the situation, and then makes a decision about what to do.
So it's not just blindly following a set of rules.
No.
It's using its understanding of language to reason through the situation.
Exactly. It's like the AI is saying, okay, based on what I know about this game and what's happening right now, here's the move that makes the most sense.
Wow.
And it can express that reasoning in a way that we can understand.
Okay. That's pretty incredible.
It is. Exactly. It's a much richer and more nuanced form of feedback.
Right.
And because these LLMs have been trained on massive amounts of text, they're capable of generating these evaluations that are surprisingly insightful.
It almost feels like we're bridging the gap between human intuition and AI decision-making.
Yeah, it's getting closer.
But the paper gets even more technical, talking about implementing things like language Monte Carlo and language temporal difference operators. I have to admit, those went a bit over my head.
Okay, well, don't worry. Those are fancy names for some pretty intuitive concepts.
Okay.
So in traditional RL, we have methods called Monte Carlo and temporal difference learning
Right.
that help the AI estimate the value of actions based on experience.
So it's like learning from your past successes and failures
Exactly. But in NLRL, we do this all in the realm of language.
in the realm of language.
Okay, it's like the AI is thinking back on its previous games,
Okay.
analyzing what worked and what didn't, but it's doing this by processing and understanding language.
So we're not just feeding the AI data. We're giving it the tools to reflect on its experiences and learn from them, just like a human would.
You got it. And this is where the power of LLMs really shines through.
Okay.
They can process these complex sequences of actions and outcomes, all represented in language, and use that to refine their strategies.
So we've got the policymaker, the critic, and now this kind of language memory
Right?
where the AI can learn from its past experiences.
Yeah.
What happens next in this NLRL pipeline?
So all of this feedback, all of this evaluation, it ultimately loops back into the policy itself.
Right.
The AI takes all this information, all these language-based insights, and uses it to refine its decision-making process.
So it's a continuous cycle of action, evaluation, reflection, and improvement,
Right.
all driven by language. It's pretty mind-blowing.
It is. It's pretty cool.
And one of the biggest potential advantages of this approach
Yeah.
is in how we train these AI systems.
Oh, yeah.
Remember, traditional RL often requires enormous amounts of data,
Tons of data.
which can be really time-consuming and expensive to collect.
Exactly. It's like those robots needing thousands of treats to learn a simple trick.
Yeah, exactly.
But NLRL offers a potential workaround,
Okay, what's that?
using language to generate synthetic training data.
Synthetic training data.
Yeah. So instead of collecting real-world data, we're creating artificial data that's specifically designed to help the AI learn.
Oh, that's interesting.
And because we're using language, we can generate this synthetic data in vast quantities, potentially accelerating the training process significantly.
Okay, now I'm really seeing the potential here.
Yeah.
But let's get down to brass tacks.
Yeah.
How well does this actually work?
Right.
Did the researchers put this NLRL system to the test?
They did. They ran a series of experiments, and the results are fascinating.
Okay, let's hear about it.
So one experiment focused on using NLRL to enhance the capabilities of LLMs through what we call prompting.
Prompting, as in giving the AI specific instructions or questions.
Exactly. They used a technique called language GPI or generalized policy iteration to guide the LLM's decision-making within a maze-solving task.
Or Maze's classic test of problem solving. So how did the AI fare?
The results were impressive.
Okay.
By using this language GPI prompting, they were able to significantly improve the LLM's ability to navigate the maze and reach the goal.
And they did this without having to retrain the entire LLM.
Yeah, pretty much.
That's remarkable.
It is.
It suggests we might be able to unlock a lot more potential from existing LLMs just by guiding them with the right language prompts.
That's the idea, and it opens up a whole new avenue for developing and deploying AI systems.
Wow.
But they didn't stop there.
Okay.
Another experiment focused on training what they call a natural language value function.
Okay. A natural language value function.
Yeah, this time they used a technique called language TD, which we touched on earlier.
Right. The language-based version of temporal difference learning.
Yeah.
So what were they training the AI to do this time?
They chose a game called Breakthrough.
Break.
It's a strategy board game where players try to move their pieces across the board.
Okay, I've heard of that one.
Yeah, the goal was to train the LLM to evaluate board positions and predict which player was likely to win, just like a human commentator might do.
So they were teaching the AI to be a sports analyst, but for board games.
Exactly, and they found that the LLM trained using this language TD approach was able to generate surprisingly accurate and insightful evaluations of the board positions, almost like a human expert.
That's really interesting.
It is.
It seems like this language TD approach could be really effective for training AI systems to understand and evaluate complex situations.
Yeah, for sure. But did they ever combine all of these concepts into like a complete NLRL system?
That's what I was going to ask.
Okay, so in their final experiment, they put it all together,
Okay.
creating a full natural language actor-critic learning system where both the actor making the decisions and the critic providing feedback were implemented using LLMs.
So the entire system was driven by language. That's impressive.
It is pretty cool. What did they use this system for?
Yeah, what did they use it for?
They tested it on the game of tic-tac-toe,
Tic-tac-toe.
which may seem simple,
Yeah.
but it's a classic benchmark for testing reinforcement learning algorithms.
Right, and it's easy to understand even for those of us who aren't AI experts.
Exactly.
Yeah.
So what were the results like?
Yeah, what happened?
The NLRL-based actor-critic system was able to learn to play tic-tac-toe at a very high level while they didn't test it against humans directly. It consistently outperformed other AI systems trained using traditional methods.
That's really promising.
Yeah, it's really cool.
It seems like this approach has the potential to create AI systems that are not only capable, but also more transparent and understandable.
Exactly. And the researchers believe this is just the beginning.
They're beginning, wow.
They see NLRL being applied to a wide range of real-world problems in the future.
That's exciting, but we also have to be realistic.
Of course.
What kind of challenges or limitations did the researchers identify?
Well, one of the biggest hurdles is computational cost. LLMs require a lot of processing power, which can make NLRL computationally expensive, especially when scaling up to more complex tasks.
So we're not going to have NLRL-powered robots running around anytime soon.
Well, not quite yet, but as computing power continues to advance, the scalability of NLRL is expected to improve.
Okay.
There's also the issue of reliance on the quality of the language models themselves.
Right. If the LLM isn't up to snuff, the whole system suffers.
Exactly. And while LLMs have made tremendous progress, they're not perfect. They can still make mistakes, misunderstand instructions, or generate output that doesn't make sense.
So there's still a lot of research and development needed to refine both the NLRL methods and the LLMs themselves.
Yeah, for sure. But it sounds like the researchers are aware of these challenges and actively working to overcome them.
It's great to hear that they're taking these issues seriously.
Absolutely. They're exploring new techniques for training LLMs, evaluating their performance, and ensuring that these systems are used responsibly.
Okay, good. So with all of that in mind, what kind of real-world applications do they envision for NLRL?
They outline a wide range of possibilities, everything from robotics and automation to education and healthcare.
Okay, so we've explored all the technical nuts and bolts of NLRL and dove into some really exciting potential applications. But what really struck me
Yeah.
is this idea that we're not just making AI smarter, we're making it more understandable. We're giving it a voice through language.
Yeah, that's the core of what makes NLRL so compelling, right? Like, it's bridging that gap between how AI learns and how we think and communicate.
Exactly.
It's about making AI a true collaborator.
And the researchers seem to believe that this isn't just, some far-off fantasy.
Right.
They envision a world where we're interacting with these AI systems,
Mm-hmm.
using natural language, like having conversations, asking questions, getting explanations
Right.
in a way that feels totally natural.
It's a pretty powerful vision, isn't it?
It is.
Imagine a world where AI isn't this like mysterious black box,
Right.
but a partner that can like explain its reasoning.
Explain its reasoning.
Yeah, help us understand complex concepts, even challenge our assumptions.
That raises a really interesting question, though.
Okay.
What happens to human expertise?
Right.
In a world where AI can explain things so clearly, do we risk becoming overly reliant on these AI systems?
It's a valid concern, but I think it's more likely that NLRL will augment human expertise, not replace it.
Okay.
Think of it like having a super intelligent research assistant.
Oh, okay.
You know, it can process vast amounts of information, identify patterns, and present them to you in a way that's easy to digest.
So it's like having an AI that can do all the heavy lifting,
Yeah, exactly.
freeing up the human experts to focus on, the higher level thinking,
Right.
the creative problem solving, the things that require like uniquely human skills.
Exactly. And because these AI systems can explain their reasoning, it allows for like a much deeper level of collaboration.
Okay.
We can question their assumptions, challenge their conclusions, and ultimately learn from each other.
It almost feels like we're entering this new era of human AI partnership, one that's built on like mutual understanding and trust.
Yeah, I like that.
But let's shift gears for a moment and talk about something that's been on my mind,
Okay.
the societal impact of all this.
Of course, yeah. Any technology with this much potential is going to have ripple effects throughout society.
What happens to jobs in a world where AI can automate so many tasks, even those that require like complex reasoning and decision making?
It's a tough question. It's one we're going to have to grapple with, but history has shown that technological advancements often create new opportunities as they displace old ones.
Okay, so while some jobs may become obsolete, new ones will emerge in fields we haven't even imagined yet.
That's the likely scenario, and it's important to focus on preparing people for those new opportunities
Right,
through education and retraining programs.
right. We need to make sure that everyone benefits from these advancements, not just a select few.
Absolutely. And we also need to be mindful of the potential for bias and misuse. These LLMs are trained on massive data sets of human language, which means they can inherit our biases, both conscious and unconscious.
So we need to be very vigilant about ensuring that these AI systems are fair, unbiased, and used ethically.
Exactly. It's a
Yeah.
responsibility that falls on all of us, researchers, developers, policymakers, and society as a whole.
This has been an incredible deep dive
It really has.
into the world of NLRL.
Yeah, fascinating stuff.
We've covered, a lot of ground,
Mm-hmm.
from the technical details to the potential applications and the societal implications. But as we wrap up, I want to leave our listeners with one final thought-provoking question.
You okay?
If NLRL truly unlocks the potential of AI to understand and communicate with us using language, what does that mean for the future of humanity?
Wow.
How will our relationship with technology change, and what kind of world will we create together?
That's a question that deserves like deep reflection. But if we approach this technology with wisdom, foresight, and a commitment to ethical principles, I believe we can harness its power to create a more just equitable and prosperous world for everyone.
I think that's a perfect note to end on. Thanks for joining us on this journey into the fascinating world of natural language reinforcement learning.
Yeah.
Until next time, keep those brains buzzing, and let's all work together to create a future where AI empowers us all